Verify whether the following are true or false. So what is that we are looking? The very first question is minus 3 a 0 of x minus 3? So we have a polynomial x minus 3. The question is minus 3 a 0 of it? I'm going to write step by step because it's going to be useful for us to understand how to represent the answer. Right? So we have 1 into x minus 3 is your actual expression. So we have to substitute x is equal to minus 3. Again, guys, there are many ways of writing it. You can write it this way. You can write it this way. All are one and the same. So I'll just go with your textbook method. Minus 3. Actually, I would prefer this. Things would be very clear to you guys. So in place of x, we are writing minus 3. So when we simplify this, what will you get? 1 into anything is the same thing. Minus 3 is minus 6. So we have, therefore, solution is what? Minus 3 is not a 0. Why? Your output turns out to be minus 6. When I make this as an input, the output turns out to be minus 6. So minus 3 is not a 0. Okay. So whenever you get any expression and any particular value, if they're asking to check, substitute that. If the output is not 0, if on simplifying it, if it's not 0, then the given input is not a 0 of the polynomial. As simple as that. So let's look at this graphically also. So I had introduced to you guys. So again, there are a few things which I'm not exactly telling how to make use of the coding that you guys will understand in time. I'll be explaining that in a separate video. Okay, now, so all I did was, see, all you have to do is, you should not be wearing any of this. If you vary also, nothing will happen, nothing will crash. That is not a big deal. You can manipulate everything, but if you want the same thing, what you guys going to look at over here, if you want the same kind of picture and all of that, then you should not vary anything other than this. In place of expression, we are going to type in the expression, whichever we want to see the graph for. So 1x minus 3 is your actual expression. So when I execute it, I get the graph. Okay, guys, as simple as that. So now, what is the 0? Technically, 0 is that value of x, right? This particular value, which makes the output to be 0. So basically, you have to look at where the graph is passing the x-axis. So this point. So what is this exact value? Well, if I just keep it on that, the actual answer is plus 3. How? See, over here, right? You guys can either zoom in or let me do both actually. So this is your x-axis. Remember, whatever I might be, how much ever I might be zooming in, the answer is the answer. So let me show this properly. Can you see that? Right? Clearly, the graph is passing the axis at 3. So 0 is your answer. Not 0, sorry. 3 is your 0. 3 is your 0. So one more place wherein you can look, like say sometime you will not be able to find the exact value. Actually, you can zoom in and find the exact value. But sometime if you are not able to, or if you don't feel like it, you just keep your mouse on that point and on the right corner in the graph here. Okay. It will tell you exactly where your mouse is pointing, the coordinates. It's approximately 3 and y is approximately 0. Can you see that? So this way also you can find, but yes, you can clearly see plus 3 is your actual 0, not minus 3. Okay, again 0 is that value which makes the output to be 0. That is when the graph passes the x-axis, that exact point, basically this point. Okay, yes, this graph is passing the x-axis at point 3. Agree? Right, 3, 0. So that's what we are trying to figure out. Next one is minus 1 by 3. Is it a 0 of 3x plus 1? Let's have a look. So p of x is plus 3x plus 1. Here, what is that we are doing? We're going to substitute minus 1 by 3. So we have 3 into minus 1 by 3 plus 1. Okay. And now we have 3 and 3 getting cancelled. And now we have minus 1 plus 1, which is equal to 0. Yes, we can tell. Therefore, the solution is that minus 1 by 3 is a 0. Okay, so let's look at this graphically also. Let me cancel this first. Let me change the variables. So the expression is what, guys? 3x plus 1. So the coefficient of x is 3. Let me change that. It's not going there. This is 3 and plus 1. Plus 1. And execution. Okay, so I need to zoom in for showing you guys this. If not, if you scroll in. Okay, so here, right, you can see approximately it's negative 0.337. So, and we have 1 by 3 minus 1 by 3, which is also equal to approximately 0. Minus, by the way, minus 0.33 bar, basically, is it not? Right? So you can see that graphically also things matches. So you need to understand graphically how things look. It will be helpful for your future. And yeah, a bit of your exams also, but still this knowledge is important, and you guys can, for every question you guys can do it yourself. I'm just getting you guys used to how to handle the coding part. Okay, you guys have to open the what is that, terminal, right? So Python coding wherein you can execute that. Let me not complicate it for you guys, and copy paste the code, right? And all you have to do is execute, change the values and execute under the expression one. That's all. So I'll be teaching you guys how to do that as well. Got it? So hopefully you guys are learning more than just telling, yeah, substitute and do all of that. You need to understand everything, pretty much all the aspect. So here p of x is plus 4 minus 5y. All we have to do is we have to substitute minus 4 by 5. That is in place of y. Sorry, this is not x. Here the polynomial is expressed in terms of y. Just another variable. Don't think too much about all of this. So minus 4 by 5. Clearly it's not a 0, but still let's do this systematically. 4, negative of negative is positive. 5 divided by 5 is 1. And this is plus 4. And this is equal to 8. So is it a 0? No. Solution is what? Minus 4 by 5 is not a 0. Clearly. Agree? Again, if you want, all we have to do is here, you can keep you have to keep the variables as x only, because I've taken the coordinates as x itself, x coordinates, and expressing in terms of y, so on and so forth. So here you can't change it to, as of now you can't, it's not that you can't permanently. Okay. If you want to change it, all of it, wherever x coordinate is there, you have to change it to y, and y per se you have to call it as something else. Okay, so that's what you have to do. But yeah, please don't change it. Nothing will happen. Big deal is it won't execute properly. You'll get an error. It's not like your system is going to crash or something. Nothing will happen. No such thing will happen. It's a very small code. But yeah, just get an idea. Get used to the idea that variables can be of different names also. Like here it's t. Even that has to be familiar. So just don't be a stereotype in that sense ki only x has to be used. No, it can be of any variable. Okay, with this I'll show you guys the coding part. So p of t is equal to t square minus 2 into t. So we have to figure out if 0 and 2 are the zeros. So all we have to do is substitute t is equal to 0. What will happen? 0 square minus 2 into 0 will be equal to 0. So the first one is verified. Let's look at the second one. P of t is equal to 2 square minus 2 into 2. So 4 minus 4, this is 0. And thus, therefore, the solution is this. 0, 2 are the zeros of p of t. Okay, guys. So I'm going to rewrite the expression as p of x is equal to x square minus 2 into x. Okay, I'm just changing the variable. So understand that variables can be of any names. So I have to equally change everywhere. So that's what I've done over there. So I have to change this to x square. So this is 1, coefficient is 1. So squaring in this is with 2 stars under 2. That is x square and plus minus 2x minus 2 into x coordinate to the power of 1. So that's good enough. Okay. So that's your 1x minus 2x. 1x square minus 2x. Is that correct? 1x square minus 2x. So this is nothing but 1. And don't do this. I mean, it's correct, but let's not do that. Okay, it's 1x square minus 2x. So now let's execute, and we have to see, okay, this won't happen. We have to see that the graph will pass. Yes, see, it's passing. Clearly it's passing 0 and it's passing the point 2. Please don't get confused. I just have to rearrange it properly, that's all. Okay, these are your zeros and zeros. Yeah, right? Clearly, graph is a smiley graph passing 0 and 2. So you can see the power of variables. I'm just have to change the name, that's it. So don't ever get confused with variables. They're just, no, we are just naming it in different manner. The concept remains the same. Okay, so this is only for our coding part. Okay, last one. Minus 3, is it a 0 of y square plus y minus 6? Let's have a look at that. So we'll call this as t of y. So you can call it any name, not an issue. Y square plus y minus 6, always write 1. And we have to figure out if t of y being equal to minus 3, will it give us 0 as the output? So 1 into minus 3 the whole square plus 1 into minus 3 minus 6. Minus 3 square is what, guys? Plus 9. Okay, so that I didn't add, I'll add over here. Square of anything, any negative number, square of, or any even power, if it raised to the power of an even number, the output is always positive. Plus 1 minus 3 is minus 3 minus 6. Clearly 6 minus, not 6, 9 minus 9 is 0. Therefore your solution is what? Yes, minus 3 is a 0 of y square plus y minus 6. 1 and 1 over there. It will help. And that is your output. That's it. Okay. Again, you guys can change the values over here and do it. I'm feeling lazy to do that. Right, the same thing. I want you guys to do that and verify. And find the other zeros also graphically. And now you can pause and have a look.